I'm going to talk about the implications for space industry and also regulators a little on this new topic that's emerged over the past couple of years, which is called dark and quiet skies. But first, I just want to mention a little bit about where I'm coming from. I recognize that this is a global audience, a lot of space sector attendees who may not be so familiar with astronomy. So I'm coming from the European Southern Observatory, and as Martinez mentioned, it's an intergovernmental organization founded on a treaty, and our main mission is to design, build, and operate the most advanced observatories on the ground. So these are world-leading facilities that allow scientists from around the world to make these famous discoveries. So unless you were living in a cave in 2019, you probably saw the image at the bottom left of my screen here, the first image of a black hole. So that was a very important scientific result. And then just above it here, that little red blob is actually the first ever image of a planet outside our own solar system, the first image of an exoplanet. And these are some of the scientific findings that we have enabled by providing these world-leading facilities. So we have 16 member states in Europe, and the observatories are all hosted in the Atacama Desert in Chile. And we have a strategic partnership with Australia at the moment. So this is one of our main facilities at the Paranal Observatory in the Atacama Desert. This is the Very Large Telescope, which is an array of 4 giant 8-meter size optical telescopes. We also are involved on the radio side. So this is the Atacama large millimeter submillimeter array, which is looking in the submillimeter wavelengths range. And we have a share in that along with the USA and Japan. And currently our main project, which is in construction at the moment, is called the Extremely Large Telescope. And this will be the world's largest optical and infrared telescope. So with a main, a primary mirror of diameter of 39 meters. So this is really, really very large. And this dome here is going to be 80 meters tall. And this is really going to be a revolution in astronomy and really, really complementary to some of the space-based facilities, such as the James Webb Space Telescope at the moment. And there you can see just a quick snapshot of how it looks like right now or a few months ago. So it's really in construction. And I just wanted to point out this picture on the left here. You can see that this is a really remote area in which we are operating our telescopes. So I'll come back to that. So why am I here at a space conference? Well, ESO, my organization, but actually all astronomers are using the space environment. So we are looking through low Earth orbit into space. So here you can see a picture of an adaptive optics laser in use on one of the Very Large Telescopes. So this is a laser that allows a dynamical correction of the disturbance in the atmosphere, so we can get much, much sharper images. But we're looking up in space, and we therefore care about the space environment a great deal. And the previous speaker had mentioned the Outer Space Treaty. When we look at it, well, we see in the first article that it recognizes that exploration of space is for all of humankind. There shall be freedom of scientific investigation. So we find a basis for our work in the first article of the Outer Space Treaty, that all users should be given access. And we've heard from the previous 2 presentations, actually, that there's this strong demand now to reduce the barriers to accessing space because of all the potential that it has. And part of this allowing freedom of access is really dependent on the sustainability of the overall environment. So this is really becoming a concern and a focus at the moment. So when we talk about space sustainability, I mean, there's lots of definitions, but this is one from the Long-Term Sustainability Working Group, which was convened by the UN Space Committee, COPUOS. So the ability to maintain the conduct of space activities out into the future, to make sure that we can all access space in an equitable way, that the benefits are shared, and most importantly, that our present needs now are met, but we're keeping the environment good for the future generations. So why is this a focus right now? Well, some of the previous speakers have already touched on this, of course. We have the aspects of the space environments that are now directly impacting the design of spacecraft, the overall mission design, and the space operational environment. So we have this huge increase in the number of space objects. The launch costs are going down. It's getting easier and easier to access space, and this is leading to a huge increase in the number of objects being launched into space. So you can see in the top left here the Space Environment Report from the European Space Agency, showing this huge increase just in the past 5 or 10 years in the number of payloads. And the increase in space objects, the increase in debris, this is really affecting now the way that operations are conducted, and in fact starting to impinge on the business model of the space sector. So we're now seeing spacecraft failures, there's fragmentations, there's this huge increase in the space debris, and it's causing spacecraft operators to think about how to deal with conjunctions. So there's this huge increase in conjunctions in certain regions. This is leading to new types of mechanisms, agreements between operators of how to deal with this, a whole new industry about space situational awareness from the ground, fleet management concepts, and discussions now about how we calculate risk and what this means for space insurance and what this means for liability. So, the bottom line here, the changing space environment, is directly affecting the long-term direction of the space sector. Now, the second issue, this is something that's a bit broader, but this is more coming from the overall concern for the environment. And there are many other stakeholders now, even outside the space sector, which are raising concerns about the business. So, one particular one is about the increasing number of satellites that are burning up in the atmosphere. So what does this mean? Do we know the effect of dumping tons and tons of aluminium and other types of unusual metals into the atmosphere at a rate that's higher than the background level from a meteorite flux? We just don't know. That's an important question. And then from my side, the impact on astronomy. So there was an article that came out just last week. You can see here the headline from the New York Times that the Hubble Space Telescope is now being affected by having satellites cross its view. So this is a new concern for even space-based observatories. So there's this general concern about the environment that is now leading to a number of space sustainability initiatives. So there's this growing public awareness, which I think is very important. And we see some activities convened by the United Nations. I mentioned this long-term sustainability working group, which are really at a sort of high level trying to define overall principles for space sustainability. But then we see some other interesting changes. So the emergence of rating schemes for industry. So one example is the Space Sustainability Rating Scheme. This is trying to encourage space actors to design and operate their space missions in a sustainable and responsible way. And the idea is that they receive a public rating that they can then advertise, showing to future regulators and future insurers that they're following good sustainability practices. We are seeing increased sort of industry expectations. So companies are now deploying resources to develop policies on space sustainability, responsible space. So here are two good examples on the screen. So there's one from OneWeb. They defined an overall approach to responsible space. There's a really great report from Inmarsat on space sustainability, which is actually a really good primer to the whole topic. We now see on the demand side, the European Space Agency, for example, has started a clean space program, and they're basically looking at sprinkling sustainability requirements across all the ESA contracts. We're seeing an increase of regulation in this area. So one example, the EU, the European Union just released the funding to start the EU sovereign satellite mega constellation called IRIS, and in the foundational document that was approved by the European Parliament, it's actually listing a set of sustainability criteria that the project has to adhere to. So any company now thinking about being involved in this, well, they had better start thinking about this subject. As I mentioned, we're seeing changes to the insurance market. So there's a UK initiative, which is sponsored by Lloyd's of London, and they're looking to create a sort of kite mark rating scheme that will help them adjust how they deal with the insurance of space projects. And in the future, well, I'm now hearing that some of the investment firms, the VC firms, are now starting to think about this broader ESG type picture and how it might affect how they invest in various projects. So operators and regulators are really having to think about these sustainability concerns. And what I'm saying is that astronomy, or the overall topic of dark and quiet skies, is now one of these broader concerns. So what do I mean by this? Well, as I've mentioned, and as you well all know, that the number of satellites is drastically increasing. So when we just tally up the numbers, I mean, you can get from anywhere from 50,000 to 450,000, and depending how you count. So for our simulations, when we're looking at the impact on observatories, we're estimating usually between 70,000 and 100,000, because we think realistically that some of these very large numbers aren't actually going to happen. But still, 70,000 is a lot of satellites. And it's not just the satellite constellations, there are other projects. So the use of passive deorbiting drag sails, I mean, this is a fantastic idea for increasing space sustainability in one dimension, but obviously it's going to impact on the visibility of these objects. There's the issue of space-based solar power, which again, for overall sustainability of Earth, for getting away from fossil fuels, this is an amazing idea. But we're talking about huge structures in low Earth orbit. So this is going to have a huge number of sustainability concerns. Astronomy in dark and quiet skies will, of course, be one. So in terms of astronomy, I mean, we've done a lot of simulations over the past few years on this. And, you've probably seen images like this in the news. And, it's basically that if you have a telescope that is seeing a very small portion of the sky, it's not so bad. You tend to get a couple to 10% of the images affected, and it's mainly at twilight. And this is when the satellites are shining the brightest, in effect, because of the geometry. However, if you are a wide field telescope, which means you're looking at a very large portion of the sky all at once, then obviously you're seeing more of the sky. There's more possibility for a satellite to go through. And now you're talking about some serious impacts. So the most famous example is the Vera Rubin Observatory, which is almost completed. It's a US project. And when it comes online next year, I mean, this is going to face serious problems with many of its images affected. And as I've mentioned, it's not just ground-based observatories. So now there's been some studies which have looked at the space observatories present in low Earth orbit. So, the Hubble Space Telescope is at about 480 kilometers altitude. So wherever it looks, it's looking through a shell of satellite constellations. And here you can see a result of that. So this is a Starlink, which was captured by the Hubble Space Telescope. And, looking at the projections, we see that up to 20% of the Hubble Space Telescope images could be affected in the future. And there's a Chinese project which is going to be launched next year, the Chinese Space Science Telescope. And this happens to have an extremely wide field of view. It's about 300 times that of the Hubble Space Telescope. And they're basically going to have every single image they take is going to have a satellite in. So they have a lot of work to do to figure out how to deal with that. So it's not all the images, it's also on the radio side, and there's several aspects here. So if you look at this image, right, this is an example of some of the beam footprints of satellites as they appear on the ground. So this is the eastern seaboard of the United States. These blue and the green and the pink circles, they are the size of the illumination of the main radio beam from these satellites. And somewhere in there's a radio quiet zone where there's a radio observatory located. And the basic issue is that none of the current international system for governing spectrum at the International Telecommunications Union deals with the ability of satellite operators to avoid radio quiet zones. Now, there are protected bands for radio astronomy, but what radio observatories can do, they can find a remote area on Earth, they can arrange they can make an agreement with the local government and say, okay, keep out all cell phones, all TVs from this radio quiet zone, and we can look at the whole spectrum. Now, what's happening with the increase in satellites is that these radio quiet zones are basically going to get rarer and rarer as more and more satellites are constantly overhead. And it's not just the illumination from the main beam, it's also the unintentional electromagnetic radiation from the satellite. So it's an electric object, it just radiates all sorts of electric noise, and the most sensitive radio telescopes can pick this up. So now, or in the future at least, there might be 5,000 to 10,000 satellites overhead at any one time, all sort of radiating low levels of electronic noise. And then another interesting issue, which again is just not covered by any of the spectrum regulation, is the reflection of radio waves from the ground, from terrestrial transmitters off satellites into radio observatories. And this is a sort of a whole new issue which astronomers are now having to think about. So what we are doing is we are making simulations. We are basically doing satellite weather maps. This is an example where we can try and avoid the satellites as much as possible. We're learning how to process the data to remove some of these streaks, but this is a sort of increasing overhead for the scientific community. So it's extra work for us. So that's why we've been asking, well, what can industry do to help us? And we've done a lot of work on this over the past few years. So this is a really nice example from SpaceX. So at the top here, you see their original Starlinks, and you can see that they're shiny, they're white, very reflective. And then over the past few years, we have worked with SpaceX, and this was their latest launch just a couple of weeks ago. And you can see that the components, the smaller components, are now darkened, and they've now introduced this dielectric mirror, which is a coating which has a variable reflectance of sunlight, and they can adjust their satellites such that all the sunlight is just reflected away, and not much of it is going to be reflected down to Earth, where it can be picked up by an observatory. So this is a really good solution, and they're actually working on now sharing this to the space sector. We've done work on, okay, what's the data that we need in terms of TLEs, and that, again, there's some good practice there. And now some of the other big operators are picking up on this. So Amazon Kuiper, they're launching some test satellites. I think it's not actually Q4, I think it's Q2, where they're going to have one with mitigations and then one without, so they can compare the difference. And also OneWeb are doing a collaborative project with astronomers to build a reflectance model and then calibrate it with actual observations of the satellite. So these are all good efforts, and we're learning a lot from the industry about how to do this. And the astronomy community has now established a center. It's called the Center for the Protection of the Dark and Quiet Skies from Satellite Constellation Interference, or the CPS. And you can point your phone on the screen here and be taken to the website. And one of the hubs that we have in this new center is called the Industry and Technology Hub. And its purpose is to share some of this information that we've learned over the past couple of years about the mitigations and about how to work together, how to collaborate with the astronomy community, and to learn all the practices that we have been developing. So I would encourage any space operators in the satellite design industry to please get in touch with us. Now, there are also a number of policy aspects which are changing right now that I think it's important for everyone to be aware. So we have been active at the United Nations Committee on the Peaceful Uses of Outer Space. So right now there's 100+ or so member states which are a member of this committee. So this is a really fantastic way to spread the knowledge about this issue and about the solutions to a wide range of countries around the world. And we have now established that astronomy should be treated as a space activity that can fall under the protection of the Outer Space Treaty, so to say. And we're also working on establishing a new expert group under the Scientific and Technical Subcommittee to really have a global approach to solving this problem. And on the national side, we're now starting to see some movement. So the US Federal Communications Commission is now requesting that operators are coordinating with the astronomy community in order to get their licenses, and they have to conclude an agreement with the US National Science Foundation. So this is a good starting model to allow operators to collaborate with the community in a solid way. And I already mentioned about the EU regulation about their new satellite mega constellation. So it has sustainability criteria. So the important thing is that we recognize that going forward, any policy and regulation, it needs to be informed by analysis, and it needs to be informed by operator practice, because this is where the learning is done by actually trying to solve some of these problems in reality. So we are not saying that all satellites should be stopped, not at all. We are saying that we need your collaboration and involvement to help us solve this issue. So I'd just like to end on some final thoughts. And here's a really nice capture of a Starlink burning up in the atmosphere, captured by a observatory in Japan. And this is it's an issue that, okay, one operator can fix it, another operator can fix it, but when we have 100 different operators, then we start to see problems of the aggregate effect, especially when we have commercial space stations or space hotels or people looking to be present permanently on the moon, which, by the way, doesn't have an atmosphere for things to burn up in. So let's really design things with sustainability in mind. So that concludes my presentation, and I am very happy to take any questions.
Thank you for that. We very much appreciate that, Andrew. I mean, that's a very insightful, and for us, in terms of speaking of sustainability, the IAC, it's one of the key core values of ours to project that and to talk about sustainability and to treat space with sustainability in mind. And I'll have a question coming up from our side too, but I have a question from the audience from Berna. So asking for, is IAU as a member of the ITU, does it engage in the consultations there?
Yeah, so the IAU is not a member of the ITU, but we do have some friendly astronomy organizations. So, for example, the Square Kilometre Array Observatory, which is a new intergovernmental radio observatory, has a membership of the ITU. And also there are regional groups. So there's one called the Committee for Radio Astronomy Frequencies in Europe, which is a collaboration between radio observatories which can attend the ITU. So we are trying to be present there. Of course, it's a matter of resources. So we find that this is something that obviously industry puts massive amounts of resources in. So we're trying to sort of compete with that in a way, but we're working on it.
And the following question I have from Arnaud. So I hope I pronounced that correct way or not. So in terms of sky pollution for the telescope, what is the maximum number of satellites in orbit?
Yeah, I mean, this is a really challenging thing to define because it's so variable depending on the number of telescopes. Sorry, the type of telescope, whether it's looking at a small part of the sky or whether it's looking at a wide portion of the sky. But I think that that there are limits that you can define, and I just want to quickly pull up this picture here. So this is showing that if you have 400,000 satellites, then in this red region, this means that 100% of your images are essentially lost. So that to me is the sort of worst case scenario where we don't want to be, because that means that it's half the sky, you can still look in the other half, but that is a kind of severe limit. And this is something that we're trying to define a more meaningful metric about a sort of threshold. Yeah, thanks. That's a great question.
Yeah, so as we running out of time, but we have one question still, so maybe possible to answer that. It's from Mikhail. So he's asking, will that very large telescope, so VLT, being built in Chile, have similar capabilities to James Webb Telescope as well?
Yes, and in some cases it will exceed it vastly because of just the size of the mirror and the light collecting power of the mirror. And a kind of final point to mention, this is often heard, was like, well, why don't you just put all the ground-based telescopes in space and then you can be away from all the interference? And if anyone is able to put a 39-meter mirror in space, please let us know.